Okay, given a force 330 newtons per meter times x plus 20 newtons per meter squared times x squared, the work done from x equals 0 to x equals 3 meters is not calculated by plugging in 3 meters to this thing to get a force and then multiplying it by a 3 meter displacement. The force changes over that 3 meters, and the only way to calculate the work is to integrate in one way or another, to integrate the force times the displacement, okay? And we then integrate from 0 to 3 meters, force of x times dx. That's what gives us our work. And if you're trying to answer a question based on the energy required to go through this displacement, or the energy attained through this displacement, you're only going to get it by integrating. So that's a fairly big error. You have to realize that you have to multiply average force times displacement, and the force you get by plugging in 3 meters is not the average force, and the force you got by plugging in 1.5 meters for that matter is not the average force, because this isn't a linear function. And adding the initial force to the final force and dividing by 2 to attempt to get the average force is not going to work for the same reason, and you can check that out. You can find the average force. You can easily integrate this and divide the result by the 3 meters, which will give you the average force. And then you can plug in 1.5 meters to get the force at the 1.5 meter position. You'll see that it's not the same as the average force. It's not going to be hugely different in this case, but in many cases there would be a really big and really important difference. And even the small difference there might be important depending on the situation to which you're trying to apply this and the results that you're trying to get.